we're going to start with our journey, explaining what we went through very quickly, and then establishing all the tools what we used and what we're going to talk about, and then directly get into our journeys, right? So we started off in 2019, and we have put it today also because we are still learning. All our learnings are together from 2019 to till. It's all here. Very glimpse of what you're going to see. This is our Go Live architecture. I didn't include any of the other component. The only component, what we're going to talk or what we're going to refer, is all on this. Microservices for observability, we had Grafana, Prometheus, OpenShift, Jaeger, and then all Elasticsearch, everything was started off with Enterprise Elasticsearch on virtual machines. We'll talk about later, I think outside of this particular thing, hey, why we are not running with Kubernetes, Elasticsearch also under the Kubernetes. Maybe we can take it offline because that needs a little more deeper in conversations, so we can take it offline. Okay, so when we started off with, it was this. We had 5 data nodes, and every machine had 8 CPUs, 32 GB RAM, and 2 TB disk. This is all we started off with. And
hello. Yep. So, like you saw in the previous slide, we are going to split our talk into multiple timelines, right? So when we started, we had 1 GB of tracing data, like 15 microservices deployed to production. So 1 month into production, what happened? So the traces increased to 100 GB. So typically everyone does performance testing for 10x, right? So we also did the same thing. 10x it was working, but in 1 month it reached 100x, from 1 GB to 100 GB. So there was utter chaos. So, typical solution to this problem is growth, right? So, but like Krishna mentioned, we had Enterprise Elasticsearch, which means per node we have to pay crores of money for a single VM. So this restricted our growth. We know the solution, but we can't grow horizontally. Horizontal scaling is the solution, right? We can't scale horizontally. So what is the solution? We started pivoting towards open source. We started embracing open source solutions. In the first slide, you saw Prometheus for monitoring, Elasticsearch, Enterprise Elasticsearch for tracing. We started embracing, like previously, we were using Dynatrace and Enterprise Elasticsearch. So we started embracing open source solutions. Yep. Now, the management was okay with scaling vertically because every node is some money, right? So you can't add more nodes because if you have to buy more nodes, you have to purchase more license. So if I go with open source, I can get rid of that budget and I can put my money on the nodes, on the open source nodes. So that is a strategy we went with. But before we jump into the solution, we thought we will analyze, we'll sit back, we'll do a forecasting. So it has grown 100x. What will it do in 1 year? So we had to store 6 months of data. So what should we do for storing 6 months of data? So that was we created a hypothesis, and we created test plan. We created performance testing, and then we arrived at a solution. Before going to this, we read the cluster characteristics, heavy volume writes. So obviously heavy volume writes, we are not expected this much amount of writes. There was heavy volume writes, and there was heavy volume reads. We didn't expect 200s of Grafana dashboards being created in 1 month. So and we didn't expect operations team to embrace the distributed tracing at that time. So this was 4 or 5 years back. So we didn't expect that. We thought they will embrace slowly, right? So 2 months, 3 months down the line, after production, operations team will embrace. So when we estimated it, so based on the data, we had 30 days of data. When we do a linear regression on 30 days of data, so within 6 months, we wanted 366 TB of data. Okay, so with each node being 4 TB, which is the ideal recommendation for an Elasticsearch node, we thought 92 nodes will be required. But this was over and above the budget of the Enterprise Elasticsearch itself. So we know this constraint, we asked for more budget, but the management, the architecture board decided the tracing is not going to grow exponentially, it is going to be constant, and hence today it is 10 TB. In 6 months, it is going to be 60 TB. You always need 60 TB. So that's the discussion which was going on. So we obviously said, trust me guys, so we have done this before, we have done this linear regression before. So it is going to be 366 TB, and then obviously client is the boss, right? So we went with 60 TB. After 5 months, we showed this chart to the client, right? So both of us were wrong. So we had expected Jaeger response data to grow to 42 TB in 6 months, but it grew to 41 TB, at most reaching the range, breaching all the calculations that we did. Within 5 months, it breached it. So we showed this chart, and we were able to negotiate, and we get 1 or 2 nodes per week and try to keep the system stable and all that. So this is why did this happen, right? So we sat back, like every month we sat back and analyzed why did this happen, because the product that we released was a hit, okay, and the users were coming into the system, more users were coming into the system, and on top of that we had a very good development team. Features are getting released every week. We are doing a release, which means microservices are also expanding from 15 to 20 to 45, 100. So it is expanding like that. So microservices are typically chatty, right? So if one request is made, it at most makes at least 10 microservice calls, right? So it is obvious that it is growing exponentially. But in the previous slide, this was the hypothesis we did, but we were hell-bent on tracing. We missed out on logs. If you see on logs, right, it's a constant growth. Why didn't the hypothesis apply to logs? So this was a constant question we had throughout our journey. But then we are platform engineers, right? So we don't listen to developers, right? So we don't listen to signals coming from developers. They were giving the signals. So when the pods crashed, they are not able to see what is wrong. So they are not able to crash logs. They are seeing delayed logs in Kibana. So whenever they have to debug something, they are not able to see. So when some error happens now, after 6 hours only they are able to debug, and all that is happening. So this is because of the log shipping issues that we had in our cluster. So we had deployed FileBeat to ship the logs to Logstash, and Logstash is shipping to Elasticsearch. So now, if you take the basic Helm chart of FileBeat, only 10 milli CPUs will be assigned to it, and this 10 milli CPUs is for a small size nodes. But we had large size nodes and Golang applications, which means you can pack more and more pods into the same node. So now, FileBeat is not able to keep up with the logs being created, and hence delay is happening. What about crash logs? This is because of how Kubernetes is working. So when container is restarted, the logs also vanish along with that. So FileBeat has to keep up. FileBeat has to keep, since FileBeat is reading the files, it has to keep up with the log lines that it is creating, right? So it cannot be 10,000 lines behind. So since we have given only 10 milli CPUs and like 20 pods are running, it is not able to ship logs in time. So we were able to give more resources to the FileBeat, and we were able to solve the problem. Now, one wise thing in our journey is JBot. We went with a JBot approach. So if you have more data in a node, then you have to keep increasing your data disk, right? So there is a limit to the size of the data disk. And in our project, there was a limit of 5 TB. So how do we break this constraint, right? So we went with a multi-partition disk. So this was allowed in Elasticsearch. We did some analysis and we went with it. This was one of the wisest decisions we did. And since we are not able to get more and more nodes, we were able to attach more and more disks and have like a tightly packed node. So at the end of 1 month, we had scaled to 10 data nodes, 16 CPU, 64 GB RAM, and a JBot architecture, which is 5 into 1 disk. So now we are in 100 GB. So we have a 30-node cluster. We have scaled from 5-node to 30-node cluster. Okay. 5 months in production. More chaos, right? So 100 GB to 1.5 TB. So as you saw in the disk usage, so now the volume is even more higher. So typically when you see more and more volumes, there are few signals that you will get in your observability system, which is your Jaeger collector pods are crashing, your Elasticsearch is flapping, your rebalance is happening, and if Jaeger pods are going down, we used OpenCensus at the time, so OpenCensus pods is also going down, and sometimes your application pods are also going down because buffering is happening in all these layers. So when write latency goes high, Jaeger pod crashes, and it's a cascading effect. So these are signals that we see in every at the beginning of every month. So we had done, like we said, in 1 month, we had estimated, so the spans per second was 3K spans per second. So we had done performance testing for 30K spans per second. And this was the numbers, right? 30K spans per second. But we were receiving pod crashes at 12K spans per second. Strangely, this was happening only at the beginning of the month or the end of the month, where the product's the usage is high. Right? So we were not able to correlate. So there was a signal coming to us. So so we heard from anonymous sources that at the beginning of the month, DB snapshots are being taken. So this was the only information that we had. So how to correlate this information, right? And we also saw high rate latency. Suddenly at the beginning of month alone, Elasticsearch will say it took 3 seconds or 5 seconds to write some information. So we thought how to correlate this. Only the Elasticsearch and everything is running in host. So we got access to the host, and we saw that write latency was high, going high in the host. Because DB snapshots were also taking, the IOPS increases, and the writes are also increasing, and which is affecting our Elasticsearch nodes and Kubernetes cluster. Obviously, we tried disk striping. We did some trial and error to see how we can, accommodate this. We tried buffering. We tried disk striping. We tried multiple disk controllers. We were using JBots. So how can we maximize this? And we even tried increasing the block size. So since we had constraints in the OS and the host level, we were using VMware. So VMware had constraints of not changing the block size for a single VM. And we had read some blogs, and we thought it would be a better idea to move to hard-code architecture. So in hindsight, this was a very big blunder that we did. So when the volume shooted up to 1.5 TB traces per day, all of us panicked. We are not expected that. So this happened like 6 months after our journey. 5 months after our journey. So we panicked. So we turned off replication. We turned off we tweaked some rebalancing parameters and all that. But what we did was, at the end of the month, we moved to hot-cold architecture, from dedicated nodes to dedicated hot nodes, dedicated cold nodes. What we didn't expect was, the data was rebalancing from hot nodes to cold nodes at the beginning, so at the end of the month, and this compounded the writes. So hello? Yeah. So now we are getting only 12K spans per second. So we are able to withstand within 12K spans per second only. But it was 30K spans per second, and adding to this, there was a compounding effect. So thinking back, it is a wrong move. And because we had moved to hot-cold architecture, there was hot spotting. So all the shards are moving from one node to another, and only 2 or 3 nodes are getting the writes. So typically in HCI architecture, so you will have some nodes in other box, like few nodes in few hosts, right? But what happened was, all the writes were going to one host, 3 nodes. So, and we realized how to solve this issue. Elasticsearch itself gives you the ability to distribute the writes across your hot nodes, which is max shards per node. So we applied max shards per node, but then rebalancing was also happening there, and so we were drastically affected during this period. It was utter chaos. We crossed that month, but there was another issue coming up. So we thought we had solved the disks issues. We thought we'll keep buffering. We did all that, and we hit the memory limits. So we used Jaeger and Elasticsearch. We still think Jaeger and Elasticsearch is a deadly combo because of the concept of nested documents, right? So what does it mean? So if you write a nested document, the metadata of the nested document should be in Elasticsearch, should be stored in Elasticsearch. In Jaeger, so when you write a span, you have the ability to append logs to it, right? So these logs are nothing but nested documents. So when you write a span, you have the ability to write around 100 logs or 120 logs. So we had kept a limit of 120 logs per span. If you write one trace is typically 10 or 15 spans, right? So when you write one trace, you are writing at most 1,500 or 2,000 documents per trace. And the metadata of the documents is kept in memory. So if you see in the left side, if this is your JVM heap, around 80% of your JVM heap is occupied by the metadata, 6 bit sets. So we were analyzing the wrong culprits. So cache memory, index memory, and all that. We were analyzing the wrong culprits, but 6 bit set was a culprit, and we had to backtrack and identify what was the issue. So at least 500 MB was. So we analyzed and found out 500 MB per index was used 500 MB per index was used for fixed bed set memory. And when we analyzed the node, we found out that at least 21 GB was used. At least 80% of your JVM heap was used for fixed bed set memory, others for other purposes. And right now, we did some analysis on storage. We had to backtrack and identify how much storage can you store, how much disk can you store per node if you have only this amount of memory, right? So if I have 21 GB fixed bit set, I can store only 42 indices per node. So 500 MB into 21 is 42 indices, with each index being 100 GB. So now our ideal sizing is 4 TB per disk. Yep, so there is a limit to everything, right? So you can say we can grow infinitely and all that, but there is a limit to everything, right? So you can ask me a few questions. So why did I not increase my JVM heap? So obvious solution is the management was in line with vertical scaling. So they said we are okay with giving you 512 GB RAM also, right? So but the problem with that 512 GB RAM is once you cross that golden number, 30 GB golden number, JVM starts doing 128-bit addressing, so which has negative impacts on your JVM. So we said, even if you give us 512 GB RAM, it is not going to solve the problem because it is going to affect us. So we'll keep with horizontal scaling philosophy itself, and we'll use only 64 GB RAM, and which means 30 GB for your JVM heap. And other questions. Why are we not sampling? This was a question everyone asked. Why are we not sampling? Why are we storing 1.5 TB traces of data? Right? So what we have established is we will use tracing data for audit. So we'll follow the latest trends, and we'll use only tracing for audit, and stop using Oracle. So stop using database for audit purposes. So we wanted to move our clients also from legacy to modern tools. And another question everyone asks is, why are we not applying back pressure? Right, obvious question. So we can write to Kafka, and since Elasticsearch is a constraint, why can't we push from stream from Kafka to Elasticsearch? So this is the very obvious question. But we have learned this in logs. So since we are applying back pressure using Logstash, there was a 6 hours delay. So there the delay is acceptable, because only in the rarest of cases we need to see the logs, but not the traces. Traces is used by the operations team also. So we said we won't apply back pressure. It is okay to drop spans, but we are not okay to lose the eyes on the system. We want live information. And yeah, I'm a platform engineer. Krishna is a platform engineer. We start blaming developers, right? So you are the guys who are causing the observability system to come down. So we say, bring down the logs, bring down the logs, bring down the traces. Like you don't have to debug everything, right? But developers don't do that. So I myself am a developer. Krishna is a developer in the previous times. So we don't do that. We have to add more logs. We have to analyze more. We have to monitor more and more systems. What is the solution for all this problem? What is the solution for all this chaos? Within 5 months in the system, we have understood one thing. So the operations team only see the latest data. They won't see the old data. So there is no point in storing the old data and keeping the memory in the JVM heap, and which is expensive for us. So we started closing the older indices, which meant it will free the bit set memory, and we can also keep the indices for audit and legal purposes. And by the end of 5 months, so we have slowly got more and more nodes from the management, like 1 or 2 nodes per every 2 weeks, and we have scaled up to 25 data nodes. And you can see in the right, this is hot nodes, 3 into 1 TB, ideal sizing recommendations, and 10 TB for cold nodes. So now we have reached 1.5 TB traces per day.
Right.
And 1 year in production. I'll hand it over to Krishna.
Okay. You have seen disk issues. You have seen memory issues. What else can go wrong? Right? So more and more things are coming up now. So we got 7 TB traces and everything, right? We fine-tuned, right? We found solutions for disk. We find solutions for memory, right? What else can go wrong? Antivirus, right? So, and they were running antiviruses in Elasticsearch nodes. And this hero we don't want, because it was hogging and it was taking more CPUs than Elasticsearch itself. So we went and then said, hey, let's not run antivirus on all these nodes. Take it out, and then we saved more CPUs for this. Another lesson. right? Another thing happened, right? This is on-prem. In AWS or in cloud, when you ask for 16 vCPU machine, 4 vCPU machine, right? Whatever you're getting it right, it is guaranteed, it is 14 CPU, 16 CPU. But that's not the case in on-prem. So in on-prem, no one will tell you, they will give you a 16 vCPU. It will act as 16 CPU today, but a month later, it may not act as 16 vCPU machine itself. So more and more things they will squeeze on it, and then the kind of hardware to virtual mapping, whenever they tweak it right, they will tweak it in such a way that you will not even know that it is still having the same CPU. So whatever parameters, whatever we tweaked, it's like this. So we'll all keep it like this, and then we'll go find day, and someone will just come and manually change something, and everything goes for a toss. So that's another thing which we dealt with, and we found it, and then we said, hey, stop doing more. No, at least in these nodes, do it somewhere else, and then someone will be able to convince that, right? And this is what purpose. The moment previously, right, the way we done things is, or based on our data, developers only searching for a day or two or something. But recently, people started doing wild searches. Hey, I want to search whether something has happened for a month, 2 months, star. They will do everything. The moment they do some kind of search like that, Elasticsearch will go for a toss, right? In all these things, whatever we try to do, we try to fix the issue from the developer. Everywhere we try to kind of help them or resolve the issues, whatever these people faced. But one thing what we actually didn't do is, these are the people who actually take the phone call from the actual customer saying, hey, something goes wrong, what is it, right? And because of all the solutions, whatever we have made so far, you saw, right, what Shakir said, we started closing all the indexes, which means if something happened in last 12 hours a day, right, everything is available. And if you want to go back a week earlier, right, they cannot do it on their own. They need to raise a ticket. We will go and manually open one index, and then we'll close the other index so that fixed with memory size, everything is all in place. And then they will do the search. Once that is done, we'll close it off. That was the only window we had. I think these are the people who didn't help. Everyone else we were able to solve, and we were able to resolve. Okay. So at the end of this journey, we moved from 25 data node to 40 node, and then people started giving us more nodes. We started adding, and then we reached from 16 CPU to 32 CPU. After we did, this happened. Exactly this happened, and then we got a notice saying you have to upgrade all your nodes. Previously, it would have been easier. Previously, we only had 25 nodes. Now we have to do it on 42 nodes, right? Patch everything, ensure that this vulnerability is no longer there. And in Shakir's slide, he explained something called the JBOD, just bunch of disks we added, right? So what we ended up doing, right, in all the 42 nodes, we ended up adding more and more disks. Now think of draining it. So when we did the calculation, in order to drain a single node, it will take a day. No way we can actually do this activity in 4 days. Not at all possible. I'm just saying 4 days as an example. They want to do as soon as possible. We projected and then said, hey, it will take a month and a half to get this particular patching work done. So these are all our learning. Allocate more CPU for antivirus or get rid of it as possible. Keep an eye on physical to virtual mapping. If you're on-prem, definitely really check whether your 16 vCPU is actually 16 vCPU. If possible, add control to prevent large-scale searches. What developer can do it, right? If you're already concerned, otherwise you don't have to do it. Listen to operation team. Have a DR strategy. The reason is if you had a Elasticsearch DR, at least the large 4J vulnerability, we would have done it in a much better way. What we would have done is said, hey, everything we'll push it to DR for now. We would have upgraded everything, and then we would have flipped the switch, and then we would have upgraded, right? That would have at least we were able to do. So, yeah. So effective golden signal dashboards and alerting is all very important. So far, everything went good, right? So knowing all these things before Diwali, management also gave us saying, hey, we know all this is going to happen. During Diwali, a lot of people are going to use our system and everything is going to happen. here is more hardware. So we took that hardware, and then what we did, okay, what are the maximum things we can do? Okay, let's allow things to scale whenever it comes in, right? We all did, and then we just thought everything is going to go smooth. But on Diwali morning, we got a call saying the system is not up. It's not even coming up. And we are wondering, hey, we didn't do anything. We got more hardware, we just scaled, and then we allowed system to scale from 2 pod to 8 pod, 8 pod to 16 pod, and horizontal replication. Everything was set, fine-tuned everything. But nothing worked. Any guess, anything, what would have happened? Okay. So what happened was a dominoes effect. One, the moment application started growing, it was trying to make more connections to the database. The moment the connection established and database starts to refuse, the application started to restart. The moment application started to restart, more and more metrics got collected, and more metrics got shipped to Prometheus. And Prometheus, high quality metrics has showed up, and Prometheus, single instance of Prometheus actually showed up memory to 32 GB. And it was not able to keep up, and then it crashed, and then it will come up. So it won't come up at all, right? It has already reached the peak, and it will come down. So because all the scaling, everything depends on Prometheus, that system itself was down, and it was not at all scaling to the actual need. So yeah, so it has a negative effect, and finally we moved to multiple Prometheus, and then we moved from single Thanos to Thanos itself. So we moved away from Prometheus. We didn't move away from Prometheus. Prometheus was still there, multiple instances, and then we were shipping Thanos. Yeah.
Yep. So now we are in 4 years. So we have our systems deployed for 4 years, and we had so many learnings, and we are slowly getting some clarity. So lesser and lesser sleepless nights, because deployments happen only in the night, and if it happens, the night is gone for us. So we have to sleep the other day, right? So everything this happens only for platform engineers. So 4 years we have get some maturity. We got some maturity and we got some clarity, and only way to scale. So we had scaled CPU, we had scaled memory, and we have scaled the disk. We have reached the sweet spot. We are adding more and more nodes. So that was the only way. So if you want to search more data, add more nodes. So that was our strategy. But guess what? So from 7.5 TB to 30 TB. So it has increased from 7.5 TB to 30 TB again. This is because the business was a hit. So the product was a hit. More and more users are getting onboarded. So the business is happy. But our platform team was not, right? So because more and more tracing is coming, so we are there are so many components to manage, but we are focusing more on the observability systems now. And our host disk saturation is happening. So it is writing 400 Mbps every second for continuously without a gap. It is writing 400 MB. So disk saturation is also happening. Till this point, we have covered everything: disk, CPU, memory, everything is covered. So we thought we are settled. So adding more and more nodes will solve the problem. So when we moved to hot cold, so we had tweaked some rebalancing parameters. We had tweaked some replication parameters to keep it stable. So we had made a configuration for throttling rebalancing. So we had attained a sweet spot of 20 Mbps. So 4 years in production, we thought, why can't we remove this parameter? So what is this parameter doing? Why can't we remove this parameter and test? So we removed it. We waited for 2 days. Nothing happened. So we also performance tested. Nothing happened. But it was at the end of the month. Beginning of the month, what happened was, unfortunately, one of the hosts went to hung state, where applications and observability nodes are running, and it restarted. It happened at 6 a.m. in the morning or something. And then within 1 hour, the application was down. So it was working fine when it was restarted, because we had applied good practices of horizontal scaling and all that for the application pods, and it was working fine. But 1 hour after restarted, it went down. And we got into a war room, and we were checking what is wrong with our systems. Every system was working fine. Particularly the observability system was yellow. Some rebalancing was happening. So we said, okay, everything is working fine, but it looks like operation success, patient dead scenario, right? So application is down. So what is the problem? So finally we asked even the network team to join the call, and when network team saw their dashboards, the network was fully saturated. So typically you will have a 25 Gbps network interface in your host, in your physical host. The entire 25 Gbps occupied for all the host. So like when we check the source and destination, both the source and destination was Elasticsearch nodes. So like when 4 or 5 nodes restarted, it has to rebalance around 100 TB of data from one host to another host. Like rebalancing is happening because we have removed the throttling. It was using as much as it can to rebalance, right? So it was using all the 25 GB to rebalance all this information, right? So we had to reapply the throttling parameters to bring the application up. So when we apply throttling, it came. So in a HCI infrastructure, always think about using separate network for your observability. Yep. So like our strategy was perfect to keep the systems up, to keep the application system up, but not with the operations. So operations had to have 1 week of data to create reports, to send the reports to CEOs, CTO of that company, right? So they had to do that. But since the volume is increasing, the fixed bit set is also increasing per day. So if it was creating 10 index in 1 year, now it was creating 40 index per day in a year, 40 index per day in 4 years, right? So now if I had allowed 7 days of searchable data to create reports, now it went down to 2 or 3 days of data, which meant operations team has to collect the reports every day and they have to collect it for a week. So now the management turned us, the operation team obviously had escalated, and management team asked us, what can we do? So even if I have to give you a budget, what is a budget that I have to give you? So that was the question they asked us. So we estimated at that time, the projection was 1.5 petabytes and we needed 512 nodes. Not happening, right? So we had increased from 42 data nodes to 67 data nodes, and this was the sweet spot we have achieved. So the management was changing. We had a new head of infrastructure, and head of engineering, and he wanted to move all the applications to cloud. So till this time it was on-prem. Now we want to move to cloud. So he had asked Krishna to move to cloud, so he will be sharing his experience.
Man, we lift and shifted everything, whatever was running on-prem, as is to cloud. The only difference being we brought in Thanos, all the changes what we brought in. So one good thing what we did, right, in Elasticsearch we configured all the traces to directly write into S3. So which means you get an elastic storage, you can write unlimited thing and you can leverage that particular thing. That actually helped a lot. Everything else remained the same. With this architecture, so we were able to store up to 3 petabytes of snapshots on Elasticsearch, and then we were able to save because there's no disk involved. So we have an elastic thing and we're able to save everything. Finally, we're able to help that last person also happily, because now there's no point of opening and closing everything, right? We also kind of automated, hey, if you want to search for something, here's the thing, if you do this particular thing, that will available. You can do whatever you want. And once that is done, another script which will get rid of that particular thing the next day. So in that way, we're able to solve that particular person also. So we are able to help everyone. And now there's a new person who joined and saying, hey, we are not happy with whatever we did. Can you guess who is that person? You solved everyone, right?
Anyone?
Any guess? Who is this new person joined and then said, I'm not happy?
Okay. So, finance team, right? Obviously. So, when we move to cloud, so there comes a separate freedom, separate independence to provision whatever you want. But with this power, with great power comes great responsibility also, right? So what happened was, we provisioned all our optimum solutions in the cloud, and cost shot up. Within 1 month, the cost shot up, and the cost of the observability was more than the cost of the product that is deployed. So the finance team asked for a separate team to not the platform and the DevOps team. They asked for a separate team to do this cost optimization. So this team has done some blunder. Let's ask a separate team to fix it. Thankfully, I was part of that team. So myself and a couple of principal engineers were working on this cost optimization. And first thing we noticed was we lifted and shifted. So whatever was in on-prem was migrated to cloud. So if it was 32 CPU in on-prem, we used the 32 CPU on cloud. So if you use ARM processors, Graviton, where you get more physical cores, like 32 CPU can be fine-tuned to 16 CPU or something like that. So if you right size itself, there is a lot of savings that you can do. And since you are in cloud, so you can leverage your discount, savings plan, reserved instances. You know you are going to keep 70 nodes always, so you can ask for RI for 3 years, and you can get Graviton discounts. You can get some private discounts. And one thing that you will miss is the data transfer. So out of your bill, if you see the bill, your 50% or 60% will be a data transfer cost in observability systems, because since you have gone to production, you will opt for high availability, multi-zone, and data transfer between multi-zone costs you. And we had created separate account for observability account, separate account for application, right? So, and we use NAT gateway since it was private account. So we used the NAT gateway to send data traffic in and out of the application account. And we missed one thing. So we were sending the tracing traffic also via NAT gateway. So which was around 30 TB at the time. 30 TB per day of NAT gateway processing charges was too high. So if you look at an year, it will be 2 crores or 3 crores just for NAT gateway processing. And on top of that, we had a hub and spoke model. So you will have a transit gateway and transit gateway attachment between two accounts, right? You have to send data to transit gateway and send it to your observability account. So that transit gateway processing charges are also added. So that will be around some 50 lakhs. So what we did was move to VPC peering connection alone. So VPC peering connection was not allowed as a principle in our projects, but we took an exception because it was cheaper and we have to process more amounts of data. So this will cut down your cost also. And we had zone aware routing in our bucket. So this was a POC, but we haven't done. So we are expected to save around 2 crores or 3 crores if you use zone aware routing. And storage. So we had when we went to cloud, we thought we will keep throughput optimized disks. We will give more IOPS to the disk. If we right size, we will get some savings. And in S3, we use the storage lifecycle management policy. So if you take a snapshot and put it in S3, it will take a snapshot to S3 standard class, right? So we moved from standard class to standard infrequent access. So why we didn't move to Glacier, maybe we'll discuss after this talk. So storage itself, we were able to reduce around $12,000 per month. Yeah. So this was a snapshot in cloud, 70 node cluster. We were storing 1 week of data. Rest of the data was going to S3, and we were using M7G, ARM processor, Graviton processor, and we had the full freedom to move to hard coal. So this was the time we had to move to hard coal. We know we had created a blunder earlier, but we know that this was the right time to move to hot and cold because we were able to size the disk correctly and keep all that, and we were able to serve only 7 days of data. Some of the metrics. So average document size in a trace was 3.91 KB, P95 is 18.9, and maximum document size in a trace was around 7 MB. And here you can see around 330 MBBS being written, and like each service pumping in like 40-50 MBBS, right? And we have 70 nodes, and if you see here, 1.2 trillion documents per week, and 140 TB for 7 days of data, and some search latency metrics. And here you can see indexing rate is 600,000 documents being written per second. Some of the learnings, right? So always have separate network for your observability stack, and decrease operational work, like respect your operations team, listen to your operations team on what has to be done, and cost as a first class citizen, and leverage S3, use SLM for Elasticsearch. Also evaluate alternatives, try to move out of JVM based solution. So ClickHouse is a good alternative. So it is a C++ based solution, and it is showing good improvements. So we did some benchmarking for ClickHouse, and we thought we could save some crores of money. Yeah.
So how many of you thought solving this problem can be done either by using horizontally scaling or vertically scaling? So if you think that is the option, right, actually it's more than that. So you need to consider all these 5 factors. It's beyond that horizontal scaling and thing, right? Who knows antivirus could be an issue, right? It is much beyond that. Who knows there will be a legal implication saying that, hey, you need to have 6 months of data, right? So it's much beyond that. So we are asking, after 4 years, hey, what if we were provided another opportunity? What are things would have changed, or what are the things we would have done? So these are the principles what we would have followed now, and these are the tools what we would have used now, so that we'll not repeat the same mistake, and this is our learning. I'm not going to read. I think we don't have a lot of time, so we can talk about it later, saying what is it, but this is what we'll be doing. Just one more thing. Remember Little's law. You cannot scale infinitely. That's not possible. So there's always going to be a constraint, so you have to operate with the constraint.
Yeah. And you won't see the importance of observability system until your application fails. And when it fails, it hits really hard because you go blind. Right? So that's why observability is important. Thank you.
Thank you.